Welcome students. Welcome to mathematics regular classes. Students, in the month of July, we have conducted a bridge course classes. Right? In the bridge course classes, we discuss some basic concepts. Okay? From today onwards, we will discuss about your regular syllabus. Okay, in your regular syllabus, the first chapter is arithmetic progression. Arithmetic progression. Okay, so in this class, we will discuss about arithmetic progressions. Okay, are you ready? Are you ready to learn about arithmetic progression? Okay, shall we start the today's session? Okay students, let's start arithmetic progression. Okay students, we have observed in nature objects such as petals of a sunflower, holes of a honeycomb, grains on a mice cob, and spirals on a pineapple, etc. We notice that these objects follows a certain pattern. Now let's move to day-to-day like situations. Situation number 1. A display of soaps in hypermarket consists of 15 rows each containing 4 fierce soaps. Then row below. Situation number 2. Roger has salary of 6,000 and an annual increment of 700. Situation 3. A city sets a fine of rupees 500 for driving without helmet. This fine increases by rupees 200 for each subsequent offences. In the examples, we notice that there is some pattern followed. We find that the succeeding term are obtained by adding a fixed number, in other by multiplying with a fixed number, in other we find that they are squares of consecutive numbers, and so on. In this chapter, we will discuss about pattern in which succeeding terms are obtained by adding a fixed number to the preceding terms. How to find nth term and the sum of nth terms of consecutive terms. Okay? Right. So, arithmetic progression. From your chapter 1, section 1.1 is the introduction part of your textbook, where certain examples and so on. Starting with section 1.0, that is the arithmetic progression. So in this chapter we will discuss the pattern in which the succeeding terms are obtained by adding the fixed number to the preceding terms. So what are the consider the list of numbers given. So here the number after is called the succeeding term and the number before is called the preceding term. Okay, again similarly here, if you see any number after is considered as the succeeding term and any number is before considering as the preceding term, so this is the preceding term and this is the succeeding term, and which is obtained after, okay, by taking a fixed number to the preceding term you will obtain the succeeding term. We shall also see how to find the nth term of the series and also the sum of n consecutive terms and use this knowledge in solving some daily life problems. Consider the following list of numbers given here. We can observe each number in the list is called as the term. So we can see the list of numbers here and we can determine the pattern or rule in which these numbers are series or written down. So we will find out the pattern. Okay. So we will find out the pattern or rule. Okay, right. In which these series of numbers or list of real numbers are written down. If you have come to the first list, you can notice that each term is one more than the term preceding it. So each number, so here you consider the first number, that is number 1. If you add 1 plus 1, you get this exceeding term, that is the 2. Again similarly, if you add 1 to the next number, it gives 3 plus 1, you get 4. So here you observe that each term is one more than the preceding term. Okay, if you come to the next list, again here we can observe that by subtracting 30 to each preceding term, you can obtain this preceding term. So this preceding term is 100. If you subtract 3 from it, you get the preceding term, that is 70. This 100 minus 30 is 70. Similarly, again if you subtract 30 from 70, you get the next place succeeding term, that is 40. Okay, similarly 40 minus 30, the next succeeding term is 10. So 30 is the fixed number which is subtracted here, and similarly if you move to the next series or list of numbers, here if each term is obtained by adding 1 to the term preceding it. So if you add minus 3 to minus 3, if you add plus 1, you get minus 2. Again add plus 1 to minus 2, add plus 1, you get minus 1. Again if you add plus 1 to minus 1, you get 0. So the fixed number which is added here is 1. Similarly, if you come here to the fourth list of number, here the 0 is either added or subtracted to obtain the same number is obtained. So here we are consider 0 is either added or subtracted to the number to obtain the succeeding number here. Okay, similarly if you come to the fifth example, we are adding minus 0.5. Okay, so let us add minus 0.5. So here we will get minus 1.5. Similarly, if you add minus 0.5 minus 1.5, get minus 2.0. Similarly, again if you add 2 minus 2 minus 0.5, you get 2.5. So minus 0.5 is added to get the preceding terms here. Okay, from all the above list of numbers, we can observe that we see that the successive terms are obtained by adding a fixed number to the preceding terms. Such list of numbers is said to form an arithmetic progression. Okay, so let us define the arithmetic progressions of our tempered Arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so here you can see that fixed number which is added here is plus 1. Okay, plus 1 is the fixed number. Here minus 30 is the fixed number. Similarly here plus 1 again. Here 0 is the fixed number which is added or subtracted, and here again minus 0.5 and minus 1 by 5 is the fixed number which is our red. Okay, the fixed number can be is called as the common difference of the AP, can be either positive or negative, or as well as we see these examples. Now let us denote the first term in our AP as A1 and the second term as A2 and the nth term as AN, and the common difference will be the arithmetic progression can be represented as even as the first term to second term A3 in the third term, and AN is the nth term. In it will be represented as a series of terms. Now we can observe that the common difference D is same between all these terms, that is A2 minus A1 is equals to A3 minus A2, and it will be again equal to the NAN minus 1 term. So the common difference will be equal in an AP sequence which is represented by D. So the general form of an AP is given as the first term minus the second term will be the plus D, the third term will be the plus 2D and A plus 3D. So the first term is AD and that is the common difference. By just knowing the first term and the common difference, we will calculate our arithmetic progression series. Then just knowing the first term and D, the common difference will be determined any term, either the first term or the second term or the third term. This is the first term and second term, this is the third term and fourth term. By just knowing the D value A and D value, we can calculate any term in an AP. There are two kinds of arithmetic progressions, that is finite arithmetic progression and infinite arithmetic progression. In finite arithmetic progression, it will have a finite number of terms in the series or list of numbers given in the last number will be mentioned in the finite arithmetic progression. Whereas an infinite arithmetic progression, there are infinite number of terms in a series or in the list of numbers that does not have the last number. See the example for the finite arithmetic progression in the total savings after every month for 10th months rupees 50 are saved in each month. So when 50 rupees are saved every month, the next month it's 50 plus 50 which will be 100 again, plus 50 it will be 150. Likewise 200 adding just 50 rupees every month, the amount will be increasing till the 10th month, and the total savings at the 10th month it will be 500. So here they have specified the duration for 10 months, so it for the finite arithmetic progression. Whereas in the infinite arithmetic progression, you can see that the last term is not specified or it is not given. Therefore, these kinds of arithmetic progressions are called as the infinite arithmetic progression. For example, before finite arithmetic progressions are given mentioned in the page number 4 in the first chapter of your textbook, that is an arithmetic progression. Now, to find out an arithmetic progression, what are the minimum things that you require? You require A, the first term, you require D, that is the common difference, or if you require both, actually you require both. So now for the first term A is 6 and the common difference D is 3, then find, let us determine the AP here. Now here it is given as an equal to 6 and D A is equals to 6 and D is equals to 3. Let us determine the AP here. So the first term will be as it is in the general form of AP is given as A comma A plus D, A plus 2D, A plus 3D. So here A is 6. So A plus D, 6 plus 3 is 9, then A plus 2D, 6 plus 2 into 3, then A plus 3 into 3, A is 6, 6 plus 3 into 3, 6 comma 9 comma 6 plus 2, 3 is a 6, 6 plus 6 is 12, again 6 plus 3, 3 is a 9, 9 plus 6 is 15. So here is the AP. Okay, right. Next, for example, for the list of numbers, determine whether it is an AP. For example, it is list of numbers, determine whether it is an AP. 6, 9, 12, 15 is an AP or not. A and D value for, let us find out here if the sequence is given to find out the first term is equal to, first term is equal to 6. We are already known that. Here we can determine the D. So D is equals to what? Is AP. The general form of AP is A plus D, A plus 2D and so on. Okay, right. So then the value of A here, the value of A is equals to 6. Then how to find the value of D? So value of D is equals to A2 minus A1. Here the A2 is 9 and A1 is 6. 9 minus 6 is equals to 3. Then A3 minus A2. 12 minus 9. 12 minus 9 is equals to, it's also 9. Then next, A4 minus A3. A4 minus A3, 15 minus 12. That is also equals to 3. Here, therefore, the common difference is A4 minus A3. A4 is 15 minus 12. 15 minus 12 is also equals to 3. So, 15 minus 12 is again, it is 3. Since the common difference is same, here the sequence is said to be an AP. So, a value is 6 and the common difference is D is 3 and this series is said to be an AP. Similarly, let us check list of numbers whether this list of numbers is a AP or not. So, the first term A here is 1. Now, we have to determine the common difference D. Okay, the common difference has to be equal between all the terms. So, let us check A2 minus A1. So, A2 minus A1, what is the value of A2? It is 1 minus 1. A2 is 1 and A1 is also 1. So, 1 minus 1 is equals to 0. Then next, A3 minus A2. A3 is 2 and A2 is 1. 2 minus 1 is 1. Next, A4 minus A3. A4, the value of A4 is 3. 3 minus 2. 3 minus 2 equals 1. 3 minus 2 equals 1. Then next a5 minus a4, a5 minus a4, 5 minus 3. So 5 minus 3 equals 5 minus 3 equals 2. So what happens here? The common difference is not same. Okay, right? You can notice that the common difference is not equal. Therefore, we can say that the sequence or the list of the numbers given above is not an AP. Next, so let us solve the example 1 from the chapter Arithmetic Progression. Example 1. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, write the first term A and the common difference D. So, we write the first term A and determine the common difference D. The first term A will be 3 by 2 as given here. The common difference D can be found out in an AP by subtracting any two consecutive numbers. So, again let us find out by D is equals to A2 minus A1. A2 is 1 by 2 and A1 is 3 by 2. So, A2 minus, that is A2 minus A1, that is 1 by 2 minus 3 by 2 is equals to S minus 2 by 2. Minus 2 by 2, 2 ones are 2 ones are, that is minus 1. Okay, so D is equals to minus 1 and A is equals to 3 by 2. Next, example number 2. Which of the following list of numbers form an AP? If they form an AP, write the next two terms. Number 1, 4, 10, 16, 22. Number 2, 1, minus 1, minus 3, minus 5. Number 3, minus 2, 2, minus 2, 2, minus 2 and so on. And number 4, 1, 1, 1, 2, 2, 2, 3, 3, 3. So, number 1. 4, 10, 16, 22. So, which of the following list of numbers form an AP? So, form an AP, we have to find the first term and also the common difference. If the common difference is same, the given list of numbers is an AP. Let's find out the common difference. So, the common difference, we have to subtract the any two consecutive numbers. So, A2 minus A1 is equals to 10 minus 4 equals 6. Then A3 minus A2 is equals to 16 minus 10, that is also 6. Then A4 minus A3 is equals to 22 minus 16. So, here the common difference, that means that the D is constant. Therefore, the given list of numbers forms an AP. Then, if they form an AP, write the next two terms. So, the next two terms are, this is an AP, and the next two terms can be obtained by adding the last term, that is 22 with 6. You get 22 plus 6, we get 28, and 28 plus 6 is 34. So, the next two terms are 28 and 34. Therefore, the AP is 4, 10, 16, 22, 28 and 34. Next, number 2. 1, minus 1, minus 3, minus 5. Here also, we have to find the common difference. So, A2 minus A1. A2 minus A1 is equals to A2 is minus 1 and A1 is 1. Minus 1 is equals to minus 2. Then A3 minus A2. A3 is minus 3. And A2 is minus 1. So, minus of minus 1. So, minus of minus 1 is equals to minus 3. Yes, minus of minus 1 is plus 2. Minus 3 plus 1 is equals to minus 2. Next, A4 minus A3. A4 is minus 5 and A3 is minus 3. So minus of minus 5, minus of minus 3. So minus 5 minus into minus plus 3. So 5 minus 5 plus 3 is equals to minus 2. So here the common difference is constant, that is minus 2. Therefore the given list of numbers forms an AP. Therefore the next two terms are, so minus 5. So we have to add minus 2 to the last term, that is minus 5. Minus 5 minus 2 is equals to minus 7, and minus 7 minus 2 is equals to minus 9. So minus 7 and minus 9 are the next two terms. Therefore the AP is 1, minus 1, minus 3, minus 5, minus 7 and minus 9. So these are the these are an examples for of AP. So which are forms an AP, which are not forms an AP. Okay students, so this is about your AP. So in this class we will discuss about the definition of AP, the general form of an AP, nth term of an AP, the first term, how to calculate the first term, common difference and so on. Okay students, in this class we discuss about the arithmetic progression introduction part. I hope you all understand. ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಇದೆ ಅಂತ ಅನ್ಸುತ್ತೆ ಮಕ್ಕಳ. ಒಂದ್ಸರಿ ನೋಡಿ, ನಿಮಗೆ ನೀಟಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಎ ಪಿನಲ್ಲಿ ಏನಿಲ್ಲ ಮಕ್ಕಳ, ನೀವು ಎ ಪಿನಲ್ಲಿ ಫಸ್ಟ್ ಟರ್ಮ್ ಮತ್ತು ಕಾಮನ್ ಡಿಫ್ರೆನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದನ್ನು ಎರಡನ್ನ ನೀವು ನೀಟಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಎ ಪಿ ಫುಲ್ ನಿಮ್ಗೆ ನೀಟಾಗಿ ಅರ್ಥ ಆದಂಗೆ. ನಾನು ಹೇಳಿದ್ದೀನಿ, ಫಸ್ಟ್ ಟರ್ಮ್ ಅಂದರೆ ಫಸ್ಟ್ ಯಾವ್ದು ಕೊಟ್ಟಿರ್ತಾರೋ ಅದೇ ಫಸ್ಟ್ ಟರ್ಮ್. ನೆಕ್ಸ್ಟ್ ಡಿನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂತಂದರೆ A2 ಗೊತ್ತಿದೆ ನಿಮಗೆ, A1 A2 A3 A4 ಗೊತ್ತಿದೆ. ಫಸ್ಟ್ ಟರ್ಮ್, ಸೆಕೆಂಡ್ ಟರ್ಮ್, ಥರ್ಡ್ ಟರ್ಮ್ ಆ್ಯಂಡ್ ಫೋರ್ತ್ ಟರ್ಮ್ ಇದೆಲ್ಲ ಗೊತ್ತಿದೆ. ಸೊ A2 ಮೈನಸ್ A1 ಅಂದರೆ ಸೆಕೆಂಡ್ ಟರ್ಮಿಂದ ಫಸ್ಟ್ ಟರ್ಮ್ನ ಮೈನಸ್ ಮಾಡಿದಾಗ ಬರುತ್ತಲ್ಲ, ಸೊ ಅದೇ ಟಿ. ಅದೇನಾದರೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದ್ದರೆ, ಈಗ A3 ಮೈನಸ್ A2 A4 ಮೈನಸ್ A3, ಸೊ ಅದನ್ನೆಲ್ಲ ನೀವು ಮೈನಸ್ ಮಾಡಿದಾಗ ಅದೆಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟೇ ಬಂದರೆ ಅದು ಎ ಪಿ ಅಂತ. ಬರಲಿಲ್ಲ ಅಂದರೆ ಎ ಪಿ ಅಲ್ಲ ಅಷ್ಟೇ. ಸೊ ಎ ಪಿ ಆಯಿತು ಅಂದರೆ ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ಸ್ನ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಅಂತ ನಾವು ಇವಾಗ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ ಅಷ್ಟೇ. ತುಂಬ ಸ್ಮಾಲ್ ಕಾನ್ಸೆಪ್ಟ್ ತೊಗೊಂಡಿದ್ದೀನಿ ಅಷ್ಟೇ, ನಿಮ್ಗೆ ಸ್ವಲ್ಪನೇ ತೊಗೊಂಡಿದ್ದೀವಿ ಅಂತ. ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೋತೀನಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ನಿಮಗೆ ಎಕ್ಸಸೈಸ್ 1.1ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಓಕೆ ರೈಟ್? ಥ್ಯಾಂಕ್ ಯು ಮಕ್ಕಳ. ಹೋಮ್ವರ್ಕ್ ನಾನು ಸೆಂಡ್ ಮಾಡ್ತೀನಿ ಏನು ಮಾಡಬೇಕಂತ, ನೀವು ಅದನ್ನು ಹೋಮ್ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ರೈಟ್? ಥ್ಯಾಂಕ್ ಯು.